Hello everyone. So welcome to the fourth video on Thevenin's theorem, and we are doing a series of videos in which we are solving the circuits using Thevenin's theorem. Okay. And the objective usually will be to find the current in a resistance or a power or voltage across a resistance. So for example, in this question you can see calculate the voltage drop across the 3 ohms resistance. So we have a 3 ohms resistance here and we need to calculate what is the voltage drop across that particular resistance. So that is the objective. Now if you again refer to my another playlist on superposition theorem, the same problem we had solved earlier. Okay, so if I go back in my notes, so we have this particular problem, calculate the voltage drop across the 3 ohm resistance. Exactly the same circuit with the same values. I have reproduced the circuit here. Now in this case we use the superposition theorem. There are 3 sources, so what is the current across each source? We use the superposition theorem, and if you notice we had to resort to using Thevenin's theorem within the superposition theorem. Okay, so this was little bit technical thing last time. You might have found a little difficult to follow, but then now you will be able to understand that also. So let us first try to solve this problem using Thevenin's theorem, and objective is that we should get the same value of the current. So in this case I don't know whether we solve this problem completely. Anyway, let's see. Let's go back to this particular problem. Let's solve it using Thevenin's theorem. Okay. So again, if you want to try based on the experience that you gained seeing last videos and based on your prior knowledge of Thevenin's theorem, if you want to solve this problem yourself, please pause the video now and take out your notes and calculator. Start working out solution of this using Thevenin's theorem using the steps that you know, and you can compare your answer with my answer. Anyway, if you want to learn, then just follow with me and you can see the solution of this particular thing. So let's solve it. So what is our load resistance here? In this case 3 ohms resistance is the load resistance. So let's mark it as A and B, and your first step, okay, step 1 is find RTH, the Thevenin's resistance. So how to find RTH? All voltage sources should be short circuited and all current sources should be open circuited. So let me draw the circuit once again. So this is completely short circuited. I have a 6 ohms above, then I have a 2 ohms here. This is short circuited and these two are open circuited. Okay, so I am having a 1 ohm resistance here, and this part is anyway short circuited, and this terminal becomes A and this terminal becomes B, and here I have removed the load resistance tree. Now simply this is nothing but we have, you know, A, B, we have 2 paths, 6 ohms and 3 ohms. Okay, so simple like 2 parallel paths. I want to find the impedance between these two or resistance between these two looking inward to the circuit. So this is nothing but RTH, 6 parallel 3. So that is nothing but 6 into 3 divided by 6 plus 3, that is 9. So I am getting 2 ohms as the Thevenin's resistance. Okay, so 2 ohms. So RTH completed. Okay. So now step 2, find VTH. Okay, so now what we have to do here is we introduce the sources back into the circuit. Okay, so let us introduce the sources back into the circuit. So I have 6 ohms here, 2 ohms here, 20 volts here, and an upward pointing 12 amperes between these 2 points, and a downward pointing 10 amperes, right? And here I have 1 ohms resistance, and then I'm having a point A here and point B here. Okay, so the question that we are asking is find VTH, nothing but what is VAB. Okay, so to find VAB we apply Kirchhoff's voltage law from B to A. So let us say I follow this path. Okay, so I come here. Now I don't know what is the voltage drop across this current source, so we cannot do that. So from B you come to here, you increase by 20, then you should know what is the current here and what is the current here. Then you can find the voltage, so VAB. Okay, so now let's solve the current. Now here you notice 10 amperes is coming down. Okay, and on this side the circuit is open, so there is no current going this side. So the entire 10 amperes will go this way. Okay, so 10 amperes will divert in this direction. 10 amperes will throw through the battery and reach this point, 10 amperes. Okay. After reaching to this point, let us say the current going upward here is X amperes. Okay, so the current going here, so here it is 10 amperes. So here it will be 10 minus X. Okay, so 10 minus X is going here. Now after coming to this point, what will be the current here? Okay. See, here 10 minus X is coming. From that again 10 is going down. So only minus X remains. But 12 is going that side. So minus X of minus 12. Okay, so that will be the current here. Okay, so minus X minus 12. So that is the current going this side. Okay, so again, if you want, I will once again draw the detail here. So here the current is 10 minus X. Now from here 10 is going down, 12 is going up. So what is going here? So simply incoming current is 10 minus X, right? That I will take 10 minus X as it is. From this I will subtract 10 and I will subtract 12. Okay, so 10 will get cancel each other. So whatever remains is minus X minus 12. Okay, so that is a current. Okay. Or you can say minus of X plus 12, but that doesn't change anything. So let's keep it as minus X minus 12, and it is flowing in the 1 ohm resistance. Okay. So now in order to find out VAB, I can find what is VAB. But then in order to exactly know what is this X, so we need to apply Kirchhoff's voltage law across one particular loop, and the loop that will help us is this loop. Okay, so the top loop, outside loop. Okay, so we cannot apply KVL through current source because we don't know what is the voltage on this. So let us apply through this entire loop. Okay, so KVL on upper loop. Okay, so just a minute. So applying KVL on upper loop. So how to apply KVL on the upper loop, this loop. Okay, so here let's start at this top left corner and go towards right. So current X is flowing in the 6 ohm resistance. So the voltage drop here going towards right is 6X, and that will have a minus sign because, okay, so let me write it here, minus 6X. So why minus 6X? Because I am going in the same direction of the current. Current goes from high voltage to low voltage, so I lose the voltage here. Then after coming here, there is no element here, there is no element here. Now I am at point A. Now I go backwards. Okay, so I am going against the current, which is minus X minus 12 and 1 ohm. So I will have plus of minus X minus 12 into 1. Okay, then I am at this point. Then again I am going against the current. So plus of 10 minus X multiplied by 2. Okay. So, and then from here I go up, so the loop ended, so this voltage will be 0. Okay. So now I got a one unknown with one equation. So minus 6X minus X minus 12 plus 10 minus X, plus 20 minus 2X equal to 0. Okay. So minus 6X minus X is minus 7X, minus 2X is minus 9X. Okay, 20 minus 12 is 8 plus 8 equal to 0, right? Just verifying. Okay, if I make a mistake, then my final answer will not match, but anyway. So now X is nothing but minus 8 divided by minus 9. So that is nothing but 8 by 9. So that is nothing but, okay, so 8 divided by 9. So it is 0.88889 amperes. Okay, so I got the value of X. Knowing the value of X, now I can find the VBA. Okay, so Thevenin's voltage VTH is nothing but VAB, which is nothing but KVL from B to A. Okay, so now let's apply KVL from B to A. So from B I'll start here, no element here, no element here. Here voltage source increasing by 20 volts. Okay, so plus 20 volts. Now I have reached here. Then I am going in the same direction of the current, so I am losing my voltage. So minus 2 multiplied by 10 minus x. Then again here I am losing my voltage. So minus of minus x minus 12 into 1. Okay, so that is nothing but my VTH. Okay, so that is nothing but 20 minus 20 plus 2x. Okay, plus x plus 12. Okay, so 20 cancels each other. So 3x plus 12. Okay, and what is x? X is nothing but 8 by 9. I don't want to use this. So 3 into 8 by 9 plus 12. Okay, so this is nothing but 8 by 3 plus 12. So that is nothing but 8 divided by 3 plus 12. So 14.6667 volt. Okay, so finally I got the Thevenin's voltage. Okay, so it's also positive. So step 3 is to draw the Thevenin circuit. Okay, so let me draw the Thevenin circuit. So here it is 2 ohms, 14.6667 volts, and then I'll introduce my load resistance back into the picture. So what is the load resistance here? 3 ohms is the load resistance. Okay, so 3 ohms. So now what is the current? Okay, so the current IL will be nothing but VTH by RTH plus RL. So that is nothing but, so 2 plus 3 is 5. Okay, so simply 14.66667 divided by 5. So I'm getting 2.9333 amperes. Okay, and what is the voltage drop across 3 ohm resistance? Nothing but into 3. So I'm getting 8.8 volts. Okay, so V 3 ohms is nothing but 8.8 volts. Okay, so I think what I last time when I solved using the superposition theorem, I think I did not solve the complete answer. So I did not verify. I think I stopped in between abruptly. So this was the superposition theorem, and I considered 20 volt source. I got 4 amperes as I1. Then considered 12 ampere source, and that itself took a long time, and I found the 1.6 amperes. So next we have to consider the 10 ampere source and then find. I think what I did, I think I left this thing in between. I did not solve the answer completely, but now no point. If I solve also, I am sure the answer will match. But you notice that Thevenin's theorem gave me the quicker result. You know, the calculation is less and the result is faster. So that's why I said I like Thevenin's theorem. Anyway, the final answer is supposed to be 2.933 amperes. And now if I refer to this, I think I left this particular problem in the middle and I just did not conclude it. Okay, so anyway, so leave it. We will not even bother to conclude this because we have our Thevenin's theorem to finally answer our question. Okay, so the answer is 2.933 amperes with 8.8 volts as the voltage drop across this 3 ohms resistance. So so I think with this I'll conclude this fourth problem. Now let's try to solve 1 or 2 more problems. Choose something interesting, something complicated, and we'll try to solve it on this topic of Thevenin's theorem. See you in the next video. Thank you.